All right, first off, congrats on finishing section 2. I'm proud of you. High fives. Now let's move on to some bigger and better things. We're going to talk about section 3, which is logical operators. And for those of you who don't know what logical operators are, they're basically founded in the simple concept of an if-then statement. So, if I'm hungry, then I'm going to go make a sandwich. That's a logical operator. So let's start with the anatomy of the if statement, what the formula syntax looks like. We're going to talk about nested logical operators so that you can test multiple logical statements in a single formula. We'll talk and or operators, two forms of the not statement, and then a handful of is statements. So there are a whole slew of is statements in Excel. We're going to talk about a number of them that I find most useful. Last but not least, two files for download. Got the PDF, Excel for Analysts, Logical Operators. Again, please feel free to download and print that, just to have them on hand as we move to the section. And then we've got our Excel file that we'll be using for hands-on demos called Section 3, Logical Operators. And that looks like this, just a single tab called Weather Data. So go ahead and open that up, open up the PDF, and let's jump in. Okay, anatomy of the if statement. The if statement or syntax is relatively simple. You've got three components of the formula: your logical test, your value if true, and your value if false. Your logical test is basically any test that results in either true or false. So you could say, test that the value of A1 equals Google, or that the numerical value in B2 is less than 100. You can also incorporate more complicated formulas here. You could say, if the max value in column A is between 25 and 30, and so on and so forth. It's literally an infinite number of tests you could put here. Next, you've got value if true. This is what you want Excel to return or to do if your test proves true. So you could just put a number or a text string here. You could also put a formula, in which case Excel would evaluate that formula if your logical test was true. And then, as you might expect, value if false does the same thing. It's what you want Excel to do in the case that your logical test is false. So let's jump into Excel and do a hands-on demo. Open the Section 3 Logical Operators document, and we'll work from there. Just to give you a quick background of what we're looking at, we've got weather data from a station at Boston Logan Airport. Don't pay too much attention because I made up some of these numbers, but you get the idea. We've got latitude, longitude, date, and month. We also have temperature and precipitation in Fahrenheit and millimeters, respectively. And from that basic information, we're going to be building out additional categorical variables like freeze, climate, precipitation type, conditions, etc., using logical operators in the rest of this section. For this lecture, we're going to start with column I, the freeze column, and all we want to do here is say, let's create a flag or a binary variable that equals yes if the temperature is freezing. In other words, if it's below 32 degrees Fahrenheit, otherwise return no. So I'm going to use an if statement to do this. We're going to take it nice and slow for the first time. Basically, I'm just going to type equals if and open the parenthesis. As you can see, this little helper box is popped up. You can see the three components that we just talked about. And again, the first thing I need is the logical test. So I'm just going to arrow over to G2, which is where my temperature field lives. Type the less than 32. So that's my test. When I hit comma, now I need to input the value if true. Since I want text here, I need to surround it in quotes. I'm just going to type yes. Comma again brings me to the value if false piece. Same idea, and type no, surrounded in quotes. Then close the parenthesis. So you'll note that I left my reference to G2 completely relative as opposed to fixing it. And that's because when I apply this formula down, I want my reference to change from G2 to G3, G4, because I always wanted to refer to the proper temperature in the proper row. So as you can see, double-click the lower right corner of the formula cell, and it has populated all the values down as far as there's data, which is exactly what I want. Now, just to kind of spot check that it's working properly, as you can see, we have some cases of missing data and NA values. Don't worry, that was intentional. We'll deal with that momentarily. But based on the values that I do have, 37 degrees is no because it's above freezing. 12 and 23 are both below freezing. It all looks good. So there you go. Basic example of using the if statement. All right, so realistically, your test may not be quite as simple and straightforward as the example we just walked through. In many cases, you have tests that include a number of different criteria and a number of different potential values. When that's the case, you're going to want to use nested if statements. The good news is that Excel makes it really easy to do this. You can include multiple logical tests within a single formula. And if you know the if formula syntax, then you know how to use nested if statements. So let's look at an example before we dive into Excel. Basically, we have another logical test here based on the temperature field in column B. But instead of just saying, is the temperature less than 32, yes or no, we're asking two questions. We're saying, is it less than 40? If not, let's see if it's greater than 80. If not, return this otherwise value if false error. So in this case, we have three potential results as opposed to two in our first instance. So basically, the syntax should look familiar. You start with your logical test. B2 is less than 40, your value if true. So in this case, if your test is true, if your temperature is less than 40, climate equals cold. Now here's the catch. When you get to the value if false piece, here's where you start your next if test. And basically, what that does is it tells Excel, all right, logically work your way from left to right through this formula and continue until you either find a test that evaluates as true or you get to the end where your value if false value lives. So in this case, it's saying, all right, is B2 less than 40, yes or no? If it is, we're going to call it cold and stop there. If it's not, we're going to move to our next test, which is our temperature greater than 80? Yes or no? If it is, call climate hot and stop there. Otherwise, move on. And in this case, if you get to the end, if you have a temperature between 40 and 80, like 55, for instance, both of these are going to evaluate false, and your cell is going to return the value if false error, or the value of false value of mild. So let's dive into Excel and get our hands dirty. We're going to be working with column J, the climate column. And basically, I want to do exactly what I just described. So I want to create a nested if statement to categorize climate as cold if the temperature is less than 40, as hot if the temperature is greater than 80, and mild otherwise. So I'll start with my equal sign. If, open the parenthesis, logical test, just like before, G2 is less than 40. Value of true is going to be cold. Now, value of false, rather than just saying hot or other here, I'm going to start another if statement. If the temperature is greater than 80, value of true, hot, in quotes because it's a text string that I want to return. And then I get to my final value if false. So if I'm done incorporating all of my tests here, and I'm ready to kind of populate my catch-all value if false message or value, I'm just going to enter that here. So it's going to be mild. And now, here's a really important note. When I add the next parenthesis, you'll see that it's orange, and it matches with the orange parenthesis, which is part of my second if statement. What that's telling me is that I'm not done with this formula. I haven't closed out all of my parentheses. So when I add the second, you'll see that it will be old and black, and it matches with the first parenthesis at the beginning of my formula, which tells me that I'm done, and I can press enter. So again, I'm going to leave the references relative so that when I populate this formula down, my references will change from row to row. So let's see if this worked. Got a bunch of cold values. Temp is below 40 in all of those instances. Here's a mild value, 43, that's correct. You can see that this is ordered by month, where 1 is January. So I may have to scroll a bit before I start getting into the hot values. So here's one in August, 85 degrees equals hot, 75 is mild. So it looks like it's working properly. There you go, basic example of using a nested if statement to add a second criteria to my test. All right, so by this point you're probably a master of the nested if statements, which is fantastic. Thing is, those statements were still based on pretty simple if this then that statements. What if we need to create a logical test that's based on a number of different fields or variables, as opposed to just temperature, for instance? One great example of this is if we wanted to create a field called precipitation type. And precipitation type can take a few different values. Let's say we want to categorize it as snow, rain, or none. If you just think about it for a minute, there's no way to define snow, rain, or none based on just a single field, because it's a function of two things, the temperature and the amount of precipitation. So if nothing's falling out of the sky, precipitation type will always be none. If precipitation is greater than 0, meaning something is coming out of the sky, we need to know if the temperature is above or below freezing to understand whether that is rain coming down or snow coming down. So that's where the and or statements come into play. It's when you need to include multiple logical tests that are based on a number of different criteria or variables. So just continuing on with the precipitation type example, you'll see that the syntax is a little bit funky. It can be a little tricky to get used to. From a readability standpoint, it might seem to make more sense to say if condition 1 and condition 2, then, in this case, Excel kind of flips it, and it always starts with if and, or if or if not, and then lists your criteria within parentheses. So, reading through this example here, this and statement, basically what we're saying is logical test 1 is if these two things are true. So if and D2 equals yes, which that's our freezing column, which tells me that the temperature is freezing, it's below 32 degrees, and C2 is greater than 0, so precipitation is greater than 0, then precipitation type equals snow. Now, if you remember the nested if syntax, instead of the value of false, we move right on into our second logical test, which is another if-and statement. In this case, we're saying if and D2 equals no, so it's not freezing, temperature's above 32 degrees, and also precipitation's greater than 0, then precipitation type equals rain. Then you're always going to wrap it up at the end with your catch-all value if false value. In this case, it's just going to be none. So in order for this test to be true, both of these conditions need to be true because it's an and statement. And then if none of these are true, it's going to return the final value, which is none. And now what if we wanted to create an additional field called conditions that are either equal to wet or dry? And the conditions are just based on precipitation. So if precipitation's none, we know that the conditions are going to be dry no matter what. If the precipitation type is rain, conditions are wet. But if the precipitation type is snow, the conditions will also be wet. So we could say if precipitation type is rain, then wet. If precipitation type is snow, then wet. Otherwise dry, and do it like a traditional nested if. Or we can get a little bit more elegant and introduce an or statement to do the same thing. So in this or statement, we're saying if or, and then listing our two conditions. Basically, this is saying if either one of these is true, then we're going to return the value of true, which is wet. So if the precipitation type equals rain or it equals snow, then conditions are wet, and then again your catch-all value with false is going to be dry. So we'll return those two values. Quick tip here, when you're writing nested functions, especially if you have a number of different logical tests all stacked together, you can just copy and paste pieces of your formula to save yourself some time. So rather than rewriting if and if or statements from scratch, just copy and paste and build your formulas that way. So let's bump over to Excel and actually walk through these examples hands-on. So again, I'm going to use the exact same conditions that I just laid out. So precipitation type is going to be the and statement that's based on freezing and precipitation. So columns I and H. I'm going to start with equals if, parenthesis, and parenthesis, and then list my two logicals that must both be true. So freezing equals, start with yes, and precipitation is greater than 0. Close the parenthesis because that's my full and statement, and then comma to my value of true. So if both of these are true, what's the deal? It's freezing, there's stuff falling from the sky. So the precipitation type is snow. And now I'm going to start with my second one. Again, I could go up here into the formula bar and copy this chunk and paste it. I'm going to type this one out just to kind of walk you through it one more time. And then later in the sections, we're going to start to do some shortcuts like that. So value of false, remember I have one more condition to test before I do my catch-all value. So I'm going to do another if and statement. In this case, I2, the freezing field, is going to be equal to no. So temperature is above 32, and precipitation is greater than 0. Close that out, comma over to value of true for this test, and that's going to be called rain. Then my last comma gets me to my final value if false. So it's if none of these tests are true, what do I want to return? And I just want none here. And then again, you need to close it out with two parentheses. I can tell that I'm done because I got the bold black parenthesis closing out my entire formula. Hit enter. Just like before, I use relative references, so I can just double-click and apply this down, and it will update automatically. And then, one way to check my values, I can just look at the filter and see, okay, all three of my potential values have populated, none, rain, and snow. I'm also getting an error value because, as we talked about, there are some blank and missing values, which we'll address momentarily. Now let's quickly do the conditions field. This is the or statement. And again, the conditions that must be true are that either the precipitation type is snow or the precipitation type is rain, in which case I'm going to call conditions wet, otherwise dry. So equals if or. Two conditions are K2 equals snow. Remember in quotes because I'm dealing with the text string, comma to my second criteria, which is K2 equals rain. Close out my or statement, comma over. If either of these are true, what value do I want to return? That value is wet. And then again, if none of those are true, my value, if false, is going to be dry. Put it in quotes, close it off, hit enter, and apply that down just like I did in the last example. And as you can see, I'm getting both dry and wet values. If I just do a quick spot check, anytime column K is none, I'm seeing a dry value. And then snow equals wet, rain equals wet. Everything looks good. So there you go. That's a quick example of how to use and or statements to develop more complicated and dynamic logical tests.
And or statements allow us to test whether conditions A and B are either both true or if one or the other is true. But what if we want to test if a condition is not true? In that case, we have a tool called the not statement, or using the not equal to operator as a means of accomplishing that. So here's an example where we want to redefine the conditions field based just on the precipitation column in column C. One way to do it would be to use the not statement and say if not C2 equals 0, which in other words is saying if C2 is not equal to 0, then value of true is wet, value of false is dry. Again, from a readability standpoint, it feels backwards. That's just the way crazy Excel operates, so you just got to get used to it. The second way to accomplish the same thing in what is, in my opinion, a more straightforward approach is to use the not equal to sign, which just looks like a less than followed immediately by a greater than symbol. So I can do the exact same thing by writing if C2 is not equal to 0, value of true, wet, value of false, dry. And it's just a little bit cleaner. Syntax is more straightforward, easy to comprehend, and you don't introduce these extra parentheses that you would by using the not statement. So jumping over to Excel, what I'm basically going to do is revisit the conditions formula that we created in the last lecture using the or statement. And I'm just going to basically delete that and start from scratch. And I'm going to use a not equal to test to accomplish the same thing. And again, I'm going to use the precipitation field as my my variable. Just going to type equals if, and then arrow over to precipitation. So if it's not equal to 0, my value of true is going to be wet. So something's fallen out of the sky, don't know what, doesn't really matter what. Otherwise, conditions are dry. One parenthesis to close it, and there you go. So now what I'm going to do is just apply this formula. It will overwrite all of my others, and because it's relative references, it will update properly. And as you can see, it maintained all of the same values. The one thing that did change, I'm just going to undo and redo to show you, is this error value in row 12. And the reason that changed is because the or statement that we had previously written, remember, was based on the precipitation type field, which had returned an error, because that field in turn was based on the temperature field, which has some corrupt or missing data. In this case, we've redefined the formula purely based on column H, which doesn't seem to have the missing value. So the error disappears and it populates properly. So there you go. That's the not statement. All right, so we talked about the if error statement briefly in lecture 6. I think it's worth revisiting here because it's especially relevant in this context. Again, it's really an excellent tool to eliminate annoying error messages and replacing those with a value of your choosing. There are a couple implications of doing that. The first is in the context of just design and polish. It can be nice as a front-end formatting tool or trick. It can also be really useful on the data side in the back end. So you may want to categorize your data consistently, whether you're seeing an error message or not, or if it's a numerical field that you're working with, and you want to be able to make statistical operations on that column of data. Sometimes having an NA value in there will prevent you from properly calculating those values. So you may want to replace the NA with something like a 0 or another value. So the syntax of the formula, again, is very simple, just two pieces. The value, which is the formula or value itself, that may or may not result in an error. And then the value if error. This is what will replace the default error symbol with whatever you choose. So again, the tip here is just write your full formula first, and then at the end, your last step will be to wrap it in an if error statement. So let's jump to Excel. And if you recall, with this weather data we're dealing with, we've got some NA values in our temperature column, which is throwing off some of the formulas that we built out in columns I, J, and K. So one by one, I'm just going to wrap each of these in an if error and set a new value to replace the NA, and we'll just apply it down and watch those error messages update. So in this case, I could assign either a no or a yes in cases where I'm getting an error, but I don't want to because I really don't know what the true underlying temperature should have been, so I don't want to just guess at it. Instead, I'm just going to define anything with an error as other. So I'm going to basically click right after my equal sign. I'm in cell I2 where my freeze formula lives, and I'm just going to type if error, open a parenthesis, and then the value, as you can see, is my entire formula that I had already written. Jump to the end, press comma, Now I'm at my value if error component, and I'm just going to type other in quotes. Sorry, I was blocking you. And close it off with one parenthesis and hit enter. So now when I apply this down, it'll overwrite all my formulas, add the if error piece, and if all goes well, replace any NAs or any other error messages with other. Boom, there you go. So NA in row 12, you can see now it says other. I've got, let's see, NAs in rows 226 and 227. Those have updated to other as well. Looks good. So let's do the exact same thing for the climate column. Type if error, open the parenthesis, jump to the end, comma, other as a string, close it off, apply the formula down, and there you go. So you might have noticed that column K originally had error messages, now it doesn't, and that's just because it was based on the errors that it was seeing in I and J, which have been corrected, so therefore the formula in column K is now good to go. So if we look at the filters, you can see the NA values disappeared. Now we just have yes, no, other. For climate, we have hot, cold, mild, or other. So there you go, using the if error statement to replace NAs with custom values. All right, let's wrap up the logical operator section by talking about the is statement. It's nice and easy. It's a good, simple one to finish on. So Excel offers a number of different is formulas. The point is that each checks whether a very particular or certain condition is true. So when you type an is function, you're just going to return either a true or a false. Those are the two possible values. Syntax-wise, it's about as easy as it possibly gets. You just write the formula, open a parenthesis, and drop in your value or reference, and close it off, and you're done. So here's a sample list. This is not comprehensive, but it should give you a sense of some of the is statements that are available to you. You can check whether your reference cell or value is blank. You can check if it's a number versus text, if you're getting an error. You can check if your value is even versus odd. You can see if it's a logical operator or a formula, and so on and so forth. So let's jump into Excel, and we're going to populate this last column, column M, called missing data. We want to identify and flag any cases where we have missing data in column G, or temperature column. So I'm going to start with an is error statement. So is error, open parenthesis, arrow over to G2, close it off, hit enter. You see I get false there because I'm getting a valid data point in G2. And then when I apply it down, you'll see it's flagged a true here in row 12 because I'm getting an error in G12. So that seems to work nicely, but before I call it a day, you'll note that I also have missing values in column G. So it's not showing an error message, but it's still a missing data point that I need to account for. So if I wanted to just flag those, what I could do is change this from is error to is blank. Again, just refer to G2. Apply that down. Now you'll see that row 6, where I have a blank, flags true, but the error in row 12 no longer flags true because it's seeing an NA error, which is not blank. So what I need to do is combine these two and flag as true any case where column G has a blank or an error value. So I'll just keep the is blank that I already have. I'm just going to start with an or, open up my parenthesis, which gives me my two logical values. Logical 1 is blank. Logical 2 is going to be is error. And just so you know, I can either click on G2 here to make that reference. I can also just type G2 and it will read it as a reference as well. Just a little tip. And then close it off. So now I have my or statement with two arguments. So if it's either blank or it's an error, this will flag as true, otherwise false. So let's see if that worked. Seems to have worked properly. I've got a blank and a true here. I've got an error and a true here. So it seems to be working properly. And now one other thing I can do here is use my filter and say, show me the cases where I have missing data, so where this flagged as true. And I can see, all right, what dates did those missing data points fall on? And then if I wanted to, I could cut that data out or manipulate it in some other way. But there you go. Those are just two examples of is statements. Again, there are a number of others. But with that wraps up logical operators. Get excited because section 4, we're going to talk about statistical functions. All right, nice work. You made it through section 3. Now it's time for some homework. Go ahead and open up the homework exercises file. Again, it's available in the course resources or in lecture 2. And jump to the second tab, the logical operators tab. Here we've got a really simple data set with some student names. We've got genders and test scores in column C. Now I have some instructions with 4 different steps. And through these steps, you're going to use logical operators and conditional statements, your if, your and, your or, to populate some additional fields in columns D through G. Now remember, if you get stuck, the answers file is also available in the course resources. Otherwise, just drop me a line and I'll be happy to help you out. Good luck. Okay, on to section 4, statistical functions. This section is all about operations that you perform on numerical data. So we're going to start with our basic stats functions. These are things like max, min, average, count, sum, standard deviation, variance, percentiles. Basic stuff there, all very straightforward. Then we're going to go into some more interesting ones, the small and large functions, the rank and the percent rank functions. We'll talk about how to build random number generators with rand and rand between. I'll go into sum product, which is a pretty powerful calculation tool. Talk countif, sumif, and averageif, and then finish up with countifs, sumifs, and averageifs, which basically do the same thing except they allow for additional criteria. And then last but not least, we'll build out a demo showing you how to build a dashboard just using sumif and countifs functions. So 2 files for download as usual. We've got our PDF called Excel for Analysts, Statistical Functions, and the Excel file called Section 4, Statistical Functions. So go ahead and open those up, and let's dive in.
All right, let's kick things off with some basic stats functions. Use the functions like count, average, median, mode, max, min, percentile, etc. Rather than dive into each one specifically, I just want to show them all here. This isn't a comprehensive list. This is kind of a list of the ones that are more commonly used, but the syntax is pretty straightforward, pretty simple to understand. Really, the only component in most of these formulas is your reference array. So, for instance, if I want to find the median of the data from A2 through A20, that's exactly how I'd write the formula. The only difference is for ones like percentile, you have an additional component of the formula to specify which percentile you want to return. So if I'm looking for the 25th percentile within a given data range, I'd put at 0.25. If I'm looking for the 75th, I'd put at 0.75. Standard deviation is stdev. Variance is var. So let's jump into Excel and see what we're working with for this section. We've got the Section 4 Statistical Functions workbook open. As you can see, there are 3 tabs here. Right now I'm in the Salary Data tab, which is our raw data. And as you can see, we've got 5 years worth of Major League Baseball salary data. So there's a year column, team, league, player, and salary. You'll also see 2 blank columns, F and G, for rank and percent rank. We'll be covering those in the next lecture. On the second tab called Basic Stats Functions, I've just got some blank cells where we're going to be calculating some of the formulas we just walked through. We'll do that in a minute. And then last but not least, first tab is Team Salary Dashboard. This is going to be our section wrap-up demo, where we're going to use data validation, countifs, and sumifs to aggregate and visualize some of this raw salary data. So fun stuff there. Let's jump into basic stats functions and just populate these cells. So I'm going to start with sample size, which basically requires a count of my data set. So I'm going to type equals count, open the parenthesis, and then here's just where I insert my data array. So I'm going to jump over to the salary data tab and select the entire column E, which is my salary column. Close the parenthesis and hit enter. and it jumps back and evaluates the formula. One thing to point out is that when you're linking data or referring to data across tabs, Excel will automatically add the tab labels there. So that's why it says salary data in single quotes, followed by the reference E. So I don't have to type any of that. As you click through, it will automatically populate for you. So let's do the average here. It's just going to be equals average salary data, column E. Average salary just over $3.5 million, which is totally nuts. Let's look at median here, which is just the median function. So as you can see, it's a very similar pattern here. So I'm going to start moving a little bit quicker. Mode is just mode. Mode is one of those functions that takes quite a while to calculate. So I'm kind of pausing here to let Excel do its thing. Usually takes 5 to 10 seconds. There you go. Not quite sure why it takes so much longer than the others. Essentially, the mode is just which number appears most often in our data set. In this case, we see that it's $1 million. Let's take a look at what the max salary is. So for maximum, I can just write max 33 million, which I believe was Alex Rodriguez. Minimum is MIN 400,000, which was the NLB minimum salary in 2010. So now we're getting into 75th percentile. So I'm going to type out percentile, select my array just like normal, but now I'm going to add a comma, and you see this little helper box popped up, and it's looking for the K value. That's just what percentile I'm looking to return. In this case, it's 75th. I'm going to put 0.75, close it off. There you go. Now to do 25th percentile, let's save ourselves a few seconds. Just copy the formula above, paste it down, change the 7 to a 2, and we've got our 25th percentile, which is just under 500,000. Standard deviation is STDEV. This is going to basically describe the spread of our data around the mean. And then variance is basically just calculated as standard deviation squared, which is going to give us a huge, huge number. Not particularly meaningful in this context, but that's the variance function. These other two, 10th highest and 100th lowest salary, we're going to cover in the next lecture. But there you go, basic stats functions. All right, so we're going to talk about a few more functions now. We're going to talk rank, small, large, and percent rank. So I'm going to start with the small and large functions, which return the nth smallest or largest values within an array. Formula syntax-wise, there's two components. You have your data array, and then the rank of the number you're trying to return. So in this case, if I write large A2 through A8, comma 2, it's going to look for the second largest number within the array A2 through A8. It looks at that array, finds that 90 is the second largest number, and it returns 90. Same story with small, it's just kind of flipped. So if I write small A2 through A8, comma 3, it's going to look for the third smallest number in the array, which in this case is 50. Rank works in a similar way, it kind of gives you a similar insight. Again, two components of the formula. You start with kind of the cell of interest or the value that you're trying to find the rank of, followed by the array in which that value lives. So by writing rank A2, comma A2, A8, we're looking for the rank of the value in A2 in the context of the array from A2 through A8. So that would return A2 because the value in A2, which is 90, is the second highest value in that array. And it kind of follows from there. You'll note that rank of A5 within A2 through A8 equals 1, which indicates that it's the highest value in the array. And the rank of A3 gives me a 7, which indicates that it's the lowest value. Next, the percent rank. It works just like rank, except it returns the rank of a value as a percentage of a given array or data set. So this formula syntax is a little bit different, but again, pretty simple, just two components. It starts with the array. So what range of data are you looking at? And then the second piece is just noted with an X, and that's which value within the range do you care about. And so it's going to tell me what the percent rank of that value x is within the context of the given array. So if I wrote a percent rank formula in column B here in this little screenshot, I'm going to see 100% for the value that's the highest in the array. So in this case, it's A14, which is 6,827. You can see it's the highest value here, which corresponds to a 100% percent rank. Same thing, the lowest value will return a 0% percent rank. So let's jump into Excel and play with these functions. So first, back to the basic stats functions tab where we left off. So for the 10th highest salary, I'm going to use a large function here. So equals large I array. It's going to be the salary column. And then I want the 10th largest, so I'm going to write 10. So $24,642,857 is the 10th highest salary in my data set. Same deal. To find the 100th lowest salary, I'm going to use the small function. My array, again, is going to be column E. And then type 100. So 405,000, which is just above minimum, is the 100th lowest value. So there you go. There's small and large. Let's jump to the salary data tab and fill in columns F and G, which are to calculate rank and percent rank. So what I want to do is find the rank of each associated salary as part of the larger range. So for this one, I'm going to start with equals rank. So it's asking for the number, which in this case is cell E2, and then the reference, which is the full array in which it lives. So here's an important distinction. First off, I'm going to use a shortcut they tell you in the first section, where I'm going to select E2, hold Control, Shift, and arrow down to give me the entire contiguous data array. The other important piece here that I need to do is fix this reference. So without touching anything, I'm going to press F4. And as you can see, it fixed that entire array from E2 through E4135. But I'm leaving the E2 as a relative reference, and you'll see why in just a minute. So if I close it out, I'm done with my rank formula. I'm going to hit Enter. This is telling me that this first player, I think it's Bobby Abreu, in 2010, has the 4,014th highest salary in the dataset. So now, because I set my references and thought about them as I was writing the formula, I should be able to just double-click to apply this formula down. And as you can see, the only thing changing in my formula is the reference to my value. So that's what I want to be changing, but I don't want the entire array to be shifting down or changing as I move this formula. So this is working properly. Percent rank, I'm going to do a really similar thing here. I'm going to type equals percent rank. The kind is flipped, so I'm going to start with the array, click E2, Control Shift arrow down, fix it with F4, comma to the X, which is the value that I care about. I'm just going to page over to E2, close it off, press Enter, and apply it down. So there you go. If you look at percentage rank and compare it against salaries, you'll see that it makes sense. So the higher percentage ranks, 86.3% for instance, is tied to a salary of 8.25 million, whereas the lowest salaries of 400,000 equate to a percent rank of 0. So there you go, small, large rank, and percent rank.
Okay, time to talk about some of my favorite functions in Excel, the rand and rand between functions. So these are essentially random number generators, and they work in slightly different ways. The first is the rand function, and when you write it, you literally just open and close the parentheses without anything in between. Just like you see here, there are a few functions in Excel, like today and now, which we'll cover in the date and time section, where you write it this way. There's actually no components to the formula besides the formula name itself. And what the rand function does is it returns a random number between 0 and 1 out to, I believe, 15 digits. Rand between is similar, except that you can specify the range that you want to determine. and it will return whole numbers between your range. So if I wrote ran between 0, 100 and filled out this array from A1 through E6, here's an example of what I might see. Keep in mind these are volatile functions, meaning that they'll recalculate or re-randomize with any workbook change, so just be aware. I'm going to jump into just a blank Excel workbook to really quickly show you what these look like. In cell A1, I'm going to do a rand function, so just RAND, open close parentheses, enter. As you'll see, I'll drag this out, drag it over, and it's just giving me a series of random numbers between 0 and 1. And if I go to the Formulas tab, click Calculate Now, you'll see that they consistently change. Now I'll just change, instead of rand, I'll do rand between, and why don't we just say 0 to 100, and then close the parenthesis. And once I apply that to the same range, you'll see that I'm dealing with similar random number generator, except in this case all my numbers are whole numbers between 0 and 100. So there you go. 2 examples of random number generators in Excel using rand and rand between. Alright, I want to quickly cover a formula here called sum product. And what the sum product formula does is multiply corresponding cells from multiple arrays and return the sum of the products. That probably sounds like complete gibberish. It's a little complicated to describe in words, but realistically it's not that bad once you understand what it's doing. So first, the syntax is actually quite simple. You just list out the arrays that you want to take the sum product of. Typically these are entire columns. Note that all your arrays have to have the same dimensions here. But to look at an example, let's say I've got a very simple data set here, just 3 products along with quantities and prices. If I want to take the total revenue for all my data, all my products, I could go row by row and say, let's calculate the revenue for apples, 2 times 50 cents. Revenue for bananas, 4 times $1. Orange is 3 times 80 cents. And then add those product level revenues to get my total of $7.40. Sum product does the same thing, just in one step. So if I take the sum product of column B, quantity, and column C, price, it's doing that exact same process. It's calculating products row by row and then summing the results to get the same value. So sum product is often used with filters. So that was a simple example, but sometimes you might want to say take the sum product, but only in cases where this column takes on a certain value. To do that, you can just replace your array reference with the array reference followed by an equal sign followed by what you want to filter on. So in this case, I want to filter where column A only equals SHAs. And you can write it just like the normal formula. The only difference, and this is a weird little nuance with Excel, is that if you don't have a filter, you separate your arrays with commas. If you do have a filter, you separate your arrays with multiplication signs. And you can add as many filters as you want here. In this last example, I'm filtering or taking a sum product only where column A equals SHAs and column B equals apple. And then when those two are true, it's also multiplying column C and D. So one kind of peek under the hood to understand how it's really working is to compare how you see the data versus how Excel is interpreting the data. So anytime you've got a filter here, it's essentially a logical test that Excel evaluates behind the scenes. So when I say A2 through A17 equals SHAs, that gets translated on the back end into a series of zeros and ones, where it's a 0 if my test is false, so if the store does not equal SHAs, and a 1 if my test is true. Same deal with column B. So if I have B equals apple, it's going to look like a 1 every time the product is apple, a 0 otherwise. And again, you don't actually see these ones and zeros. This is just kind of how Excel is doing the math behind the scenes. So if we were to have a sum product formula like this, which is taking the sum product of A times B times C times D, as you can see, only rows that satisfy all conditions or all filters will produce a non-zero sum, because as soon as one of my filters fails, I'm going to get a 0 in that row, which is going to make the entire row zero out or be excluded from the sum. So basically that's how the filter's working behind the scenes. And that's sum product in a nutshell.
All right, now we're getting into the really good stuff. Count if, sum if, average if. This is where we're starting to build formulas that really open the door to let us create some really cool, powerful, dynamic things in Excel. So right now we're looking at count if, sum if, and average if. And I'm going to skip this slide, and I'll tell you why. It's because each of those functions also have a pluralized version. So count ifs, sum ifs, and average ifs with an S at the end. The only difference is that these functions allow you to do the exact same thing, but include multiple criteria instead of just one. And the syntax is kind of different. So rather than teaching you the syntax for the singular versions, and then immediately teaching you a different syntax for the pluralized versions, let's just focus on count ifs, sum ifs, and average ifs, because you can use these versions of the formulas even if you're just using one criteria. But they open the door for you to include additional ones if you choose. So these are kind of the ideal ones to use. I actually haven't used a singular version in, God, I don't even know how long. So let's focus on these for now. Basically, what these do is they allow you to evaluate a count, sum, or average based on multiple conditions or criteria. So syntax-wise, count if basically consists of a combination of criteria ranges and criteria. So you'll see criteria range 1, criteria 1, criteria range 2, criteria 2. And this extends for as many criteria as you want to include. So let's say our criteria that we want to factor into this count is the campaign name. So we want to take the count where the campaign name equals Google, for instance. In that case, the criteria range is going to be whichever column contains my campaign names. And the criteria 1, criteria itself, is going to be Google, in quotes, as a string. Sum ifs and average ifs work the same way. There's just one additional piece, and that's right up front. You lead with either your sum range or your average range. So the sum range is the range of actual values that you want to take the sum of, followed by all of your criteria ranges and individual criteria. So I know it's a little bit confusing at first, but I promise once you read a few of these, they'll start to become really, really natural. So let's just kind of slowly take some time to walk through these 3 examples listed here. First off, count ifs. So again, we're just listing the criteria ranges followed by the criteria. So my first criteria range is column B. I'm just looking at 13 rows of data, so B2 through B13, which is different tactics, either search or display. In this case, only take the count where B equals search, and where D, which is my clicks column, is greater than 200. And you're probably wondering, hey, that's a numerical filter, why you putting quotes around it? It's not a string. And I wish I could tell you why that's the case. It's just the case. What you use, greater than or less than, in a sum if or a count if or an average if, for some crazy reason you gotta surround it in quotes. Trust me, I tried 1,000 other ways, kept getting errors, didn't know why, and then realized this was how it works. So again, another one of those little nuances that you learn once and then you never forget it. So that's count if. It returns a result of 3, because there are 3 instances where B equals search and the click volume is greater than 200. So sum ifs, now I need my sum range first, remember. So I'm indicating our item as sum ifs, column D, this is what I want to sum, where column A equals February and column B equals display. So it's going to look at all the rows where both those cases are true, and then take the sum of the clicks column, which is my sum range. Same exact thing with average ifs. So the average range is going to be column D, my clicks again, and I want to average column D when column A equals January and column C equals MSN. So there you go. That's count ifs sum ifs, and average ifs. In the next lecture, we're going to talk about putting these into practice to build our first dynamic dashboard. So get pumped.
All right, let's build ourselves a dashboard. We're going to use countifs here. We're going to use sum ifs here. We're also going to build in some data validation, which we covered in the first section. And basically the idea here is to take the raw data that we have and create a dynamic little dashboard along with a visual to kind of give you an idea of how these functions can be used as a really cool actual analytical tool. So I'm on the team salary dashboard tab of the section for statistical functions Excel workbook. And the first step that I'm going to do is to turn cell C2 into a data validation cell. And basically I want it to allow a list of all the unique values for each team, and that's it. So first thing I need is that source list. To get that, I'm going to click the salary data tab. I'm going to start in B2, Control Shift arrow down, and hit Control C to copy. Now I'm just going to create a new tab here and paste that data. This is kind of just a scrap sheet, and without deselecting it, I'm just going to go to the data tab, hit the remove duplicate buttons, and hit OK. That will tell me that 33 unique values remain, which are each of the individual team names. So I'll hit OK. That's going to become the source list for my data validation dropdown. So let's jump back to team salary dashboard, back to cell C2, go into data, data validation, click the data validation button, and then in the allow dropdown, we're going to choose list, and in the source section, we're going to choose the data selector there, jump to sheet 2, select A1, Control Shift arrow down to A33, and then press that same button again to lock it in. So now if we press OK, we've got our drop-down list of each team. So that's step 1. Step 2 is actually populating this array of data using a countif and a sum if formula to pull in the correct data based on the team and the year. So as you can tell, there are 2 criteria that we're dealing with here, which means we have to use the sum ifs and count ifs versions of the functions. So let's get started. For total salary, since we're going to be summing an actual data range, we need to use a sum ifs here. So I'm going to start with the sum ifs formula, open the parenthesis, and remember my first component is the sum range. So what am I taking the sum of? Well, this is the salary column, so I'm going to be taking the sum of salary. That data lives in the salary data sheet in column E. So I'm going to select that whole column. I'm going to press F4 to lock it in, just in case this formula moves from column to column. I want to always calculate salary in this case. I'm going to hit the comma to get to my criteria range 1. So I have 2 criteria that I'm working with here, team and year. It doesn't matter which order I go in. I could set my team criteria first, then year, or vice versa. So in this case, let's just do team first. So criteria range 1 is the range in which my first criteria values live. So if I'm doing team first, that's going to be column B. Again, I'll lock it in with the F4 shortcut. And then when I comma over, the next piece that I need is the actual criteria that I'm looking to pull out of range 1 or looking to identify within range 1. And that value is going to be found in cell C2. So I'm going to lock that again. That means whatever team name is populated in cell C2 is going to be fed into this sum ifs formula. So comma over, now I'm on criteria range 2. So my second criteria is the year. So where do my years live? They live in salary data column A. Again, F4 to fix it. And then comma to my last piece of the function, which is criteria 2. So how do I know what year I care about in this instance? If I go back to the dashboard tab, I care about the year in column B, and in this case it's the value in B5 because I'm dealing with the total salary for 2010. Now an important point of distinction here, if I were to lock B5 in completely with the F4 shortcut, close the parenthesis, and enter the formula, I'm getting the correct salary for 2010 for Arizona. If I drag this down, you'll see that I get the exact same salary every single time. The reason that's the case is because if you watch the formula itself, as I click down, nothing's changing because every reference is completely fixed. That's almost correct, except the one thing that I do want to shift is the reference to the year name. It's kind of tough to see there, but if I scroll down and hit F2 to kind of dive in, you can see that in every case I'm referring to B5 and only B5. So if I go back into my original formula in C5, I want the B to be fixed, but I want the 5 to shift to row 6, 7, 8, and 9 as I move this formula down. So I'm just going to remove the fixed reference before the 5 and press enter again. Now if I apply this down, it will update properly. So that's my total salary column. For the number of players, in this case we don't want to sum any values, we just want to take a count of the number of players under those same two criteria, team and year. So I'm just going to do equals countifs, criteria range 1, which is team. So where do my teams live? Salary data, column B, fix it. And what's my criteria? Whatever team I've selected in cell C2. Criteria range 2 is year. Where do my years live? Salary data, column A. And then criteria 2 is whatever year that I care about, which is in B5. And I'm going to hit F4 3 times to cycle through until I've fixed the B but not the 5. Close the parenthesis, hit enter, and there you go. So this is telling me that Arizona has 26 players in the data sample for 2010, 27 for 2011 and 12, and so on and so forth. So for average salary, you could use an average ifs here. What I'm going to do, since I have the total salary and I have the number of players, I'm just going to take the simple route and just use simple division here. So I'm going to take C5 divided by the number of players. So team salary divided by number of players equals average salary per player. And I'm just going to apply that down. And if I want to get rid of these decimals, I can go into the Home tab and just hit this decrease decimal button twice. And now I've rounded to the nearest dollar. So there you go. This chart is already tied to the data in those ranges, so it will update automatically as you cycle through. Now you can see how each team has kind of adjusted their salaries and how the average salaries have changed over time. So there you go. Pretty simple example of how to build a dynamic dashboard and how to use these formulas in more of an analytical way. Alright, so that wraps up the statistical functions section. Next up we have lookup reference functions, which is one of my favorite sections, so get excited. Alright, time for section 4, homework. Go ahead and open up the homework exercises file. Now we're on the third tab, stats functions, and here we've got a basic data set in columns A through E. We're looking at product category and SKUs by location, and we're measuring sales and revenue. So what we're going to do here is walk through 3 steps to use functions like sumif, sumifs, and countifs to pull out specific subsets of this data and populate the cells above. And remember, if you get stuck, you've got the answer file available to you in the course resources. Good luck.